Welcome to Alphanumeric Tricks. In this video, we are going to see the problems under elimination of arbitrary constants. Now we will see the first problem. We have to form a PDE by eliminating the arbitrary constants from z is equal to ax plus by plus a square plus b square. Now we will see the solution. We have to take the given problem as equation 1. Our method is you have to differentiate the given problem partially with respect to the independent variables x and y. After that, using the differentiated term and the given problem, we try to eliminate the arbitrary constants. Before going to start with this problem, we can predict the order of the resulting PDE. How it is possible is using the arbitrary constants and the independent variables. In our problem, the number of arbitrary constants here is 2, which is a and b, and the number of independent variables is also equal to 2, which is x and y. So that both are equal, resulting PDE we obtained is first order. So from this we can say that we just differentiate, that is we just find out the derivatives p and q, that is enough. Now we differentiate the given problem partially with respect to the independent variable x. What is differentiation of z with respect to x? Dou z by dou x is equal to differentiation of ax with respect to x is a, because a into x differentiation with respect to x is 1, plus by plus a squared plus b squared terms are taken as constant because we are doing partial derivative with respect to x. So constant differentiation becomes 0. And the notation for dou z by dou x is p. So p is equal to a, number that has 2. Again, differentiating 1 partially with respect to the another independent variable y. What is differentiation of z with respect to y? Dou z by dou y is equal to differentiation of ax with respect to y becomes 0 because it is constant, plus by differentiation is b, plus the a squared plus b squared is constant, so differentiation of constant becomes 0. And dou z by dou y is taken as q is equal to b. We have to, using 1, 2 and 3, try to eliminate the arbitrary constants. Here using 2 and 3 alone is not possible. So but the values of a and b are readily available in equations 2 and 3. So just substitute 2 and 3 in equation 1, the constants will be eliminated. So you have z is equal to, instead of a, you can take replace p, so px plus, and this b is replaced by q, so qy plus p square plus q square, which is our required partial differential equation. And we recheck this, order of this equation will be equal to 1 because p, the derivative p is dou z by dou x, first order. Similarly q is dou z by dou y, that is also order 1. So the maximum order equation here is 1. So we get the first order PDE. Now we will see the next problem. We have to form a PDE by elimination of arbitrary constants from z is equal to x squared plus a into y squared plus b. Now we will see the solution. Here also the number of independent variables here is 2, which is x and y, and the arbitrary constants are a and b, which is 2. So both are equal. The resulting PDE we obtained is first order. From that we can say that we just find out the derivatives p and q alone. Now we will pass on to the solution. We take the given problem to be equal to 1. and differentiating 1 partially with respect to the independent variable x, that is z is differentiated partially with respect to x. So dou z by dou x is equal to, here you have x squared plus a is taken as one term and y squared plus b is another term. So these two terms are in product. When you are doing product, the differentiation, one term is, that is y squared plus b here is constant because derivative, partial derivative with respect to x's we are doing. So y squared plus b you have to take as it is, that is constant, write as it is, into differentiation of x squared becomes 2x plus a differentiation with respect to x becomes 0. So dou z by dou x is equal to 2x into y squared plus b. But the notation, standard notation for dou z by dou x is p is equal to 2x into y squared plus b. Now you can take 2x to another side. So we get the value of y squared plus b to substitute to 1. So we have y squared plus b is equal to p by 2x. Number that is equation 2. Now we have to differentiate 1 again partially with respect to another independent variable y. So here also differentiation of z with respect to y becomes dou z by dou y, which is taken as q, and these two terms are in product, and here differentiation is partially with respect to y. So x squared plus a term is taken as constant. So you write as it is into differentiation of y squared plus b is 2y, because differentiation of y squared is 2y plus constant differentiation becomes 0. So 2y into x squared plus a. Again you have to take this 2y to another side. You can get the value of x squared plus a. So x squared plus a is equal to q divided by q, 2y. Now from 2 and 3 we can say that the values of x squared plus a and y squared plus b are readily available. So just substitute these values in equation 1. So substituting 2 and 3 in equation 1, we get z is equal to x squared plus a is replaced by q by 2y into y squared plus b is replaced by p by 2x, and denominator you have 2y into 2x, you have 4xy. You take that 4xy to another side. So 4xy z is equal to pq. Here also the maximum order here is first order, that is p is dou z by dou x and q is dou z by dou y, which is our required PDE. That's all for today's session. We will see some more problems in the next video. If you have any doubts on this topic, provide in the comment section. Thanks for your time and thanks for watching.